At what time between 2 and 3 o'clock will the hands of a clock be together? So the time is 2 o'clock. This minute hand needs to overlap this hour hand. We'll calculate that, but before that, let me tell you what is the distance between these two hands. Right? Actually, the minute hand and the hour hand are 10-minute spaces apart. Right? This is 5-minute space and this is 5-minute space. So in all, they are 10-minute spaces apart. Right. Now to overlap the hour hand, the minute hand will have to cover up more than 10-minute spaces. Right. Now let me take you back to one of the concepts that we learned about clocks previously. And this is that concept. It is said that in 1 hour, the difference between the minute spaces traveled by the minute hand and the hour hand is 55. That means in 1 hour, the hour hand will travel 5-minute spaces, right? And the minute hand will travel 60-minute spaces. So actually the difference is 55-minute spaces. In other words, it means that the minute hand has gained 55-minute space more than the hour hand. If you're finding it still confusing, forget about the minutes here. Just take the unit as space. So in 1 hour, the minute hand is actually 55 spaces ahead of the hour hand. Okay, so let us apply this logic in our question. So in 1 hour, the minute hand gains 55 spaces over the hour hand. Okay, now we need to gain 10 spaces in order to overlap this hour hand, right? The minute hand needs to gain 10 minute spaces. So again, we can write it as 10 spaces gained in x minutes by minute hand, and we have to calculate the x. So we can just cross multiply and equate. So x is equals to 60 times 10 divided by 55. Okay, 5 times 11 is 55, 5 times 2 is 60. So this is 120 by 11. And if you solve it, you'll get 10 by 11 minutes. So in order to overlap this hour hand, this minute hand will take 10 by 11 minutes, right? So the answer is option A. At what time in minutes between 3 o'clock and 4 o'clock both the needles will coincide each other? So this is the current situation of the clock at 3 o'clock, right? So what is the distance between the hour hand and the minute hand? Well, the distance is 15 minute spaces, right? In other words, I can call it 15 spaces. So in order to coincide with the hour hand, the minute hand needs to gain 15 minute spaces or 15 spaces. And we know that in 1 hour or in 60 minutes, the minute hand gains 55 spaces over the hour hand. So what amount of minutes are required by the minute hand to gain 15 minute spaces? Right. So cross multiply and equate. We get x is equals to 60 times 15 divided by 55. And 5 times 11 is 55, 5 times 3 is 15. So 180 divided by 11. And that can be written as 16 4 by 11 minutes. Right? So this much time is required by the minute hand to coincide with the hour hand. So option D is the correct answer. At what time between 7 and 8 o'clock will the hands of a clock be in the same straight line but not together? Okay, so the first clock is at 7 o'clock, right? And what is the distance between the minute hand and the hour hand? Well, it is this distance, and that is 25 spaces, right? 5, 10, 15, 20 and 25, right? And when the hands are in a straight line but not together, the distance we know is actually 30 spaces, isn't it? Well, how much must a minute hand gain in order to come in a straight line with the hour hand? Well, 30 spaces minus 25 spaces, isn't it? Because it just needs to gain 5 spaces in order to come in a straight line, right? So the spaces needed to gain is 5 spaces. And we know how much a minute hand gains over an hour hand in 1 hour. So in 60 minutes, the minute hand gains 55 spaces, right? And in how many minutes will it gain 5 spaces? Right, just cross multiply and equate. So I have x is equal to 60 times 5 divided by 55, and 5 times 11 is 55, so 60 divided by 11, right? 11 5s are 55, and what's the remainder? Well, the remainder is 5. So 5 by 11 minutes, and this will be past 7, right? In order to get both the hands straight in a line but not together. So option D is the correct answer.